Welcome. This is our second lesson for load flow study using ETAP. Right now, our screen, from the right side on our screen, these symbols are in line with ANSI standard. For today, we're going to use IEC standard. To change this, let's go to project, then standards, and let's select IEC, and the frequency will be 50 hertz. As you can see, now these symbols here are now being aligned to IEC standard. Okay, so let's start now making our single line diagram. Let's provide first the power grid. Okay, then a bus. Next, a two-winding transformer. Then, at the bottom of two-winding transformer, another bus. Then, an induction motor. Okay. So, let's connect this power grid to the bus. On the primary side of the transformer also going to the bus. And the secondary side of the transformer, let's connect to the bus. And the induction motor also is going to connect to the secondary bus of the transformer. Okay, so from here, we're going to add a static load. Okay, so this is the static load. We connect it from here. Okay, we're going to connect it to the bus. Okay, so after that, we're going to provide the values of the transformer, of our induction motor, and our static load. Okay, so first we're going to provide the value of our two-winding transformer. So just click this symbol here. Okay, then the rating. Since we are adopting IEC standard, the system voltage also will going to in line with IEC standard. So for the primary voltage, let's say 11 kV here, and the secondary voltage to be 400 volts or 0.4 kV. Okay, and we assign the value of our transformer to be 1.6 MVA. Okay, so from type and class, the type of transformer is only, we can say, liquid fill, and the subtype to be mineral oil, the class to be ONAN, and the temperature lies, let's say, 65. And the impedance here, we're going to utilize the ETAP library by clicking this typical impedance and XR ratio. Okay, and just click OK. So we have here for the induction motor. Okay, let's provide the information for induction motor also here. Okay, so let's go to the nameplate. Okay, and since we don't have, we're going to utilize our library from ETAP. Okay, just click the library. Okay, and check in kilowatt, because normally in IEC the value of the motors are in kilowatts. So let's select the 0.4 kV here, and let's say we're going to utilize the 200 kilowatt from here. Okay, just click OK, and if you can see here, ETAP library automatically fill up all the information required, such as the kilowatt, the kV, the number of poles, the full load amperes, the power factor, and the efficiency of the motors. Okay, just click OK. So from here, we can provide also, if we have, for example, this bus is having 5 of the same rating 200 kilowatt motors and the same characteristic. So from here, we can choose, we can provide the number of motors from here. Let's say we have 5 the same rating of motors. So let's provide here 5. Okay. Now we have here 5 times 200 kilowatt. Also for the static load, let's say we can assign from the loading, we can assign around 0.4 400 kVA or 0.4 MVA. So 0.4 MVA here. Okay. Now for load flow, we just ensure, let's click the power grid. Let's just ensure that the operation mode is in swing. It's already here. Okay. Just click OK. Now, this single line diagram is ready to run for load flow analysis. Let's click the left side, the P and Q here for the load flow analysis. Okay. But before that, let's go to the load flow study case. Just click this. Okay. Go to the alert level. If you can see here, these are the values already, a default value already given by ETAP. Okay, for the transformer, if our load reaches to 100, it will give an alert because it is in critical value. And also if it is reaches to 95%, the load, it will be fall into marginal. Okay. Also for the bus voltage, if the bus reaches to 95%, that will be in critical value. While on the marginal, if it is reaches to 98%. So this will be okay. We're not going to change anything here. So we'll just press OK from here. Okay. Now, we're going to run the ETAP. Just press this P and Q here on the right side of the screen. Okay. So right now, you can see here, there is an alert. Now our transformer on our 400 volt bus changed into different color. It was in black before. Right now it is in pink color. So let's check what are these alerts. Okay, just click this alert view. Okay, we can check it from here. Okay, let's make this one bigger. Okay, so right now, we don't have in critical value, but we have in marginal value. Both the 400 volt, okay, bus and our transformer. Why? In the bus, in a 400 volt bus, we have, it is operating in 97% only. We have here at 388 volts. While for our transformer, it is operating in 96.6%, equivalent to 1.545 MVA, wherein our transformer is 1.6 MVA. So both the transformer is overloaded while our bus is under voltage. Okay, so how to resolve this issue? Just let's close this load flow analysis alert view. Okay, so first, to resolve the issue of overloading of the transformer, let's increase the size of the transformer. Right now it is 1.6 MVA. So double click this one. We'll go to the rating of the transformer. Let's change this one to 2 MVA. Okay. Right now, Our 400 volt bus is having 97.03% of the nominal voltage of the bus. So how to resolve this? How are we going to adjust this voltage here on the bus? We'll just go to the transformer top here. From here, to make this voltage higher, we'll just go to the top, and on the primary side, okay, we're going to select, because normally the transformer is having, for this type of transformer, let's say we're having 5 steps. One is nominal, and the other 4 steps is positive, negative 2.5%. So right now, let's click this and select 2.5. Meaning, if the primary selected negative, the voltage on the bus will change, will become higher. Okay, so we selected negative 2.5%. Okay, just click OK. Now, we're going to run again the load flow analysis. If you can see from here, there's that before the transformer and the 400 volt bus is in alert view. It was changed into different color. It was changed into pink. Right now it is in black. So right now we're going to check the alert. The alert view is nothing from here. It's empty. So meaning there's no abnormal situation right now on our power system. Since, if you can see from here, our transformer is having rated 2 MVA, but the power flow going to this bus is only 1,523 or 1.523 MVA. So we are not overloaded anymore with regards to the transformer. And to our 400 volt bus, it was before, it was around 97%. Now we have already 100.3%. So both we corrected the overloaded transformer and the under voltage on our 400 volt bus.